equations, and this is three variable. When you have three variables, you need to have three equations. And when you don't, you have what is called automatic problem. Because what it represents is two planes that intersect and create a line and have infinitely many solutions. So this represents infinitely many solutions. So when you were in grade, high school, maybe you still are, and you solved a system of equations before and they ended up being infinitely many solutions, that's all you had to do. You would write infinitely many solutions, a little sideways 8, you would smile your way to the next problem. Not anymore. Now you can solve for an arbitrary variable that will represent all of those infinite solutions. And in this case, our arbitrary variable is y. Now, knowing what your arbitrary variable is should make something happen in your brain. That means that every other variable needs to be written in terms of that variable. So don't eliminate y. All right, so whatever your arbitrary variable is, don't eliminate that one. So as I look at this system, I'm going to add them together because it's going to allow me to eliminate the z variable. And it's going to show me the line that I would get if these two planes intersected. And I'm going to get 7x plus 6y is equal to negative 3. That's going to be the line that I end up with. How interesting. Now, when we get a system of three, variables, just like we did in that prior problem with the money, we got three answers: 10,000, 5,000, 10,000, x, y, z. So we're going to have an x, y, z here as well. But the y is just going to be y. Our job is to figure out what x and z are in terms of y. Now, the thing about y is y can be any number because, like I said, it's infinitely many solutions. So you can plug in a 0, you can plug in a 1, you can plug in anything and come up with an infinite set of three value solutions: x, y, z, x, y, z, x, y, z forever. And this line has an infinite number of points on it. So now that we've added the two together and we eliminated the z, don't eliminate the y because that's your arbitrary variable, we're going to solve this equation for x because that's what we want to find out. So subtract 6y on both sides, and we end up with 7x is equal to 3 minus, and that's a negative 3, equal to negative 3 minus 6y. All I have to do is divide by 7, and everything's beautiful. I have negative 3 minus 6y over 7. Now, how on earth are we going to find out what z is? It looks to me like we're going to be plugging in these values back into these equations right here. So I'm going to start with the top equation, and I'm going to plug in right there. So wherever I see an x, I'm going to put this value that I just got here, this negative 3 minus 6y over 7. So 3 times negative 3 minus 6y over 7 plus y plus z is equal to 5. All right, I see what you're saying in your mind. I don't want to see those fractions. I don't want to do anything with those things. Well, okay, well, let's do something about that. If we go ahead and multiply by 7, just to get rid of the fraction, we're going to have 3 times the numerator, negative 3 minus 6y, because multiplying by 7 right here just cancels in the denominator, plus 7y plus 7z plus 35. Now, I'm a big fan of clearing fractions because they make our lives a lot easier. We don't have to find common denominators. Good stuff. So we distribute here, we get negative 9 minus 18y plus 7y plus 7z. Now, our goal is to get z all by itself, so that means we need to move everything over here with the 35. But we don't need to rush. We need to go ahead and get our like terms together that we can on this side. So we got negative 9 minus 11y, because we put these two together, plus 7z is equal to 35. So far, so good. Move this 9 over here with the 35 by adding it. So that's going to be negative 11y plus 7z is equal to 43. No, 44. Important to add, right? Use your calculator if you must. I know 10 will give us 45, so 9 will give us 44. And when you add it, it's a positive still. And then we're going to move this 11 over. So we get 7z is equal to 44 plus 11y. And we're almost there. Then we divide by 7, and we get z all by itself. And this is our z, which is 44 plus 11y over 7. Now, we have solved this problem. And this is the weirdest solution you might ever see in your life, but it represents one of many sets of infinite triples, infinite XYZ solutions to this line where these two planes intersect. Well, I hope that you enjoyed this review. I hope it helped you, and that if you have any questions, maybe it sparked some and you'll reach out and I can help you out. At any rate, good luck with all of your finals, especially this one.